So today's question is zero array transformation. So I have given an array nums and length of it is n and a 2D array queries where query of I is left index, right index. So for each query you have to select a subset of indices within the range left and right in nums, and we have to decrement that selected indices by one. A zero array is an array where all the elements are equal to zero. We have to return true if it's possible to transform nums into a zero array after processing all the queries subsequently. Otherwise, we have to return false. So we'll check what is the test case to better understand the problem statement. So we have given a queries list which will have multiple queries. So for let's suppose for the first query, the range is from 0 to 3. We will decrement every element in the array if it's non-zero. So if it's zero, we don't decrement. If it's non-zero, only we'll decrement. So this is non-zero, this is non-zero, this is non-zero, this is non-zero. So we'll decrement all of them. So after decrementing all the indices from 0 to 3, which is 1, 2, 3 and 1, we'll get 0, we'll get 1, we'll get 2, we'll get 0, 5 will be as it is, 1 will be as it is. So after the first iteration of the first query, we will get the resultant array as this. After the For the second query, it will be this to this 0, 1, 2, 3, 4, 5, 4, 5, and we have to decrement it because it's non-zero. So we have to decrement it 0, 1, 2, 0, 4, 1, 4, 0, sorry. So 4, 0. This is the resultant array after the second query. So we'll remove, we have completed that. And for the last one, this is the sub array, and we have to decrement both of them because we want zero array. So after decrementing, we'll get 0, 1 minus 1 is 0, 2 minus 1 is 1, this should be 0, this is 4, and this is 0. So this is our resultant array after all the queries. We have exhausted from all the queries. So this is our resultant array, but this is not a zero array. So we'll return false. We have to return false because this complete array is not zero. So we have to return false. So we'll check the brute force first. Brute force approach is very easy for this algorithm. We'll directly go from left to right in the nums array. This is the zeroth index, this is the third index. We'll decrement every non-zero element from the range 0 to 3. So this is 1, so we can decrement, this will become 0. We can decrement this, this will become 1. We can decrement this, this will become 2. We can decrement this, it will become 0. So our first query is exhausted. So we'll go to the next query, which is 4 comma 5. 4 comma 5 is here, so we have to decrement 5, it will become 4. We have to decrement 1, it will become 0. So we have taken the second array as well, second query as well. Third is 1 comma 2, so we have to decrement 2, which was previously made 1 by this particular query. We'll make this as it was 1 and it would become 0. And 2, this was 3, it was 2 after this particular query, so it will become 1. So the resultant array would be the same as this we have done. So it will become, this will decrement, this would decrement twice because in this range and in this range is present, so it will become 0. And this also will decrement, this will decrement only once, so it will become 2. This is 3, so 3 is there, so we'll decrement that, it will become 0. We'll decrement this, it will become 4, this will become 0. Oh, sorry, this will become 0 because it's in the index. Sorry. this will become 1 because it's both in this query as well as in this query. So this will be reduced by 2, this will also reduce by 2, this will reduce by 1 because in this query itself it's becoming 0. So we don't need any more queries to make it negative. So here the time complexity is big O of Q into N. Q is number of queries that we have to iterate and N is the number of elements in the array. So in the worst case, a query could contain 0 to N. It's a possible query. So for that, this would be N, and simultaneously I have to go through every query. So this would be big O of N. So if you consider Q as N, it would become big O of N square. Big O of N square is not possible as the constraint N is 10 power 5. So if we multiply 10 power 5 into 10 power 5, it would become, which is N square, you can say. N square is, this is N square is 10 power 10, which is greater than 10 power 8. So we'll get TLE. So for this, we have to think a different approach, and that is difference array. Difference array is used for range related questions. This is a range related question. As you can see, we have given a range 0 to 3, and where you need to either increment or decrement in a range. So in this particular particular example, we were decrementing by -1. So this is a perfect example for difference array approach. So the very good thing about the difference array approach is that we can update the ranges with big O of 1. So why it works, we'll check that first. So suppose that we want to increment the interval 1 to 2 with 5. So we'll note down the array which is 0, 0, 0, 0, 0. What could be the resultant array after adding 5 to 1 and 2? It would be 0, 5, 5, 0, 0. That's it. So we have to somehow get to this particular result. So how could we do using difference array? So here the difference array states that if we want to add any particular k value from a particular starting index, it will start from starting index, but it will go till the last element. So after that we'll get 0, 5, 5, 5, and 5. But we don't want this particular values. So it states that after this we can also start a different query where it starts from index ending index plus 1, which is 3, to the ending index of the array, which is 4, and you can add -5 so that it gets neutralized and gets compensated for this particular extra values. So for that, if we do, so I'll note down the array here. So the array is 0, 5, 5, 5, 5. So the range, the new range is, this is 0, 1, 2, 3, 4. So 3 comma 4 is the new range, and the new k is -5. So we have to add -5. So it will add here -5. It will add here -5. So the resultant array would become 0, 5, 5, 0. 5 plus -5 is 0, and 5 plus -5 is 0. So this is the resultant array, and this is what we actually needed. So once we'll see the algorithm, for this particular question, which is very similar to difference array approach, only this last step is extra. So first we'll see the first step is we have to make a prefix array of size n, which is the num's length. Then we will add k for the starting index and minus k for the ending index plus 1. Sorry, I have not written plus 1 here. Plus 1. So ending index plus 1, we have to decrease, we have to add minus k. So after all the queries, we'll take the prefix sum. Prefix sum, I'll explain you what is prefix sum. We'll dry run and I'll explain all the steps. After that, we have to add nums array, which is the original array that we have to find if it can become a zero array or not. And then prefix array, we have to add this both array. And after that, we have to check if the nums array becomes zero. If it becomes zero, we'll have to return true. Otherwise, we have to return false. So we'll go through a complete dry run for the particular algorithm. So initially the array is, so initially we have to take a prefix sum of the same length. After making the prefix sum, we'll see what is the next step. We have to add k for the starting index x minus k for the ending index plus 1. For this particular query, the starting index is 0, 0, 1, 2, 3, 4, 5. Starting index is 0 and we have to decrement, which is k is equal to minus 1 and minus k will be plus 1. So we have to add k here, which is minus 1, and we have to decrement k, which is minus k. We have to minus k here, which is ending index plus 1, which is 4 here. So this is done. So the next is 4 comma 5. 4 comma 5 is minus 1. Here we'll add k. My plus 5 plus 1 is 6. 6 is out of bounds. So we don't do anything. This is also completed. We'll take 1 comma 2. 1 is this. We'll add k. And 2 plus 1 is 3. We will add minus k. Minus k is plus 1. So after that, if you see the resultant prefix sum, would be minus 1. This is also minus 1. This is 0. That is 1. That is 0. 1 minus 1 plus 0 is 0. And this is also 0. So after that, we'll check what is the next step. We have done the second step. After that, after all the queries, we will take the prefix sum of the prefix array. So after taking the prefix sum, we'll check what will be the prefix array. This would be minus 1 because nothing is before that. This would be minus 2. Minus 1 plus minus 1 is minus 2. 0 minus 2 is minus 2. 1 minus 2 is minus 1. 0 minus 1 is minus 1 and 0 minus 1 is minus 1. So this is our prefix array. So let's check what is the next step. Next step is we have to add the nums array and the prefix array. What is nums array? 1, 2, 3, 1, 5, 1. I'll note it down here. 1, 2, 3, 1, 5, 1. So if we add both the arrays, we'll get this is 0, this is 0, this is 1, this is 0, this is 4, and this is 0. So this is our resultant array, and this is not a zero array. So we'll return false. So we'll return false. So if you see in the starting, we have done the brute force method and we got the same result 001 040. For this also we got the same result. So that means difference array approach is working. So we'll see the time complexity for this approach here itself. So we are going for every query plus we are doing we are adding nums array and prefix array, so which is 1 big O of n. So if we consider q as n, so it would become big O of 2n, which is approximately big O of n. So let's go to Leetcode and put it up. Step is will declare a prefix array of the same size as the num slot length. Then what is the next second step? We'll check here. The second step is we have to iterate through all the queries and then we have to add k for the starting index and minus k for the ending index. So we have to go through every query plus plus. I will take the starting index as queries of I of 0 and ending index is equal to query of I of sorry 1. So we'll make prefix of starting index plus plus because k is minus 1, so we have to decrement here, sorry, have to decrement here, and we have to check if the ending index plus 1 is less than num slot length. We'll check if it's in bounds, then only we'll do prefix of ending index plus 1 plus plus because minus k is plus 1 here. So after that we have to, let's see what is the next step. The next step is we have to add all the numbers in the prefix sum. We have to do prefix sum in prefix array. So it will start from I is equal to 1. It will go to, sorry, it will go to prefix dot length I plus plus and prefix dot I is plus equals because we are doing prefix sum I minus 1. So from this loop we got the prefix sum. Then what is the next step? We have to add nums of array and nums of prefix. So for int I is equal to 0, I less than prefix dot length I plus plus some nums of I is equal to nums of I plus prefix of I. So here directly we'll check if nums of I is greater than 0 because we don't want anyone greater than 0. It could be negative, no problem. The meaning of negative is that it 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 at one point was 0. So after that we don't have the choice to decrease. So negative also is fine, but positive value greater than 0 value is not required. So we'll return directly false here. After all this, we'll return, we'll run this, we'll submit. So for this is the complete code for today's problem of the day. Hope you like it. Please like, share, and subscribe to my channel. Thank you.